Welcome to my second class of Fourier series. In the first class, we already discussed what are the applications in engineering field in the Fourier series, who is invented Fourier series, why you need to study for Fourier series. This thing, and also if you want to study for Fourier series, what are the prerequisites are required to study for Fourier series? These things we discussed in my first class. Now welcome to my second class. In this second class, we are going to discuss how to construct a Fourier series for the function in the corresponding interval. Now before I am going to start engineering level to construction of Fourier series, let us first try to know generally how to construct Fourier series for the given function. If you want to construct a Fourier series, for the function, one of the condition is function must be defined in certain interval. For example, here I consider f of x is defined in the interval a comma a plus 2l. No, like just like 0 to 2 or minus by 2 pi, like that. Keep in mind, if you want to construct a Fourier series, function must be defined in certain limit. Now, even though the function is defined in certain limit, you can't step into the construction of Fourier series. It must be satisfies some conditions. The conditions are function is a periodic function in the corresponding interval. For example, here I consider the function is defined in the interval a comma a plus 2l. Therefore, function is a periodic function in the interval a comma a plus 2l. And also function is continuous in the corresponding interval. Not necessary it must be a continuous. It may be having a point of discontinuity. The condition is it must be having finite number of simple point of discontinuities in the interval. And also function may be having a finite number of maximum or minimum value in the corresponding interval a comma a plus 2l, or it may be don't have any maxima minima in the corresponding interval a comma a plus 2l. Once you satisfy these conditions, then we move to construct Fourier series for the function in the corresponding interval. Suppose it's not satisfied any one of these conditions, it's not possible to construct Fourier series. Combining these three conditions, they are treated as Dirichlet conditions. If you want to consider in one line, if you want to construct a Fourier series in the corresponding interval, it must be satisfies Dirichlet conditions. Suppose it's not satisfied any one of these conditions, now we are not possible to construct Fourier series in the corresponding interval. But in engineering level, not necessary to verify for the function in the corresponding interval whether it satisfies or not. What are the functions we are going to consider in engineering level and engineering textbook? Though already verified the function in the corresponding interval is satisfies the Dirichlet condition. Your job is only to construct Fourier series in the corresponding interval. Imagine what are the functions we are going to expecting in engineering level is already verified. But I am explaining generally. Once you move to the core subject, there how to know where I am going to use Fourier series, Z transform, Fourier transform, wavelet transform, fast Fourier transform. If we want to know that, that's why I am explaining generally how to construct Fourier series. The final conclusion is, if you want to construct the Fourier series, the function must be defined in the interval, and also the function must be satisfied the conditions of Dirichlet's. Otherwise, it's not possible to construct the Fourier series. For example, we already studied in the first order and first degree differential equation in first year. If you want to solve first order and first degree differential equation, using exact differential equation is not possible always. It must be satisfied one of the condition. What is the condition? Dou m by dou y equals dou n by dou x. Then only moving to construct or moving to find out the solution of the first order and first degree differential equation. like that. If you want to construct the Fourier series in the corresponding interval, it must be satisfies these conditions. I already told in my previous class, whenever function is not periodic, there we are going to use, instead of Fourier series, is Fourier transform. Now, I move to the next step. No, don't confuse. This is a general definition of construction of Fourier series. These conditions must be satisfied. Then only move to construct the Fourier series. But in your level, not necessary to verify these conditions. Now, what are the functions we are going to consider in engineering level is already verified. Such type of function only they are going to ask in the exam, and also they discuss in the textbook. Now, you have a function, for example, f of x is a function defined over interval a comma a plus 2l. I want to construct, this is a general construction for Fourier series. This is a general formula. Suppose function is defined in the interval a comma a plus 2l. What's the formula for construction of Fourier series? Formula for construction of Fourier series is a naught by 2 plus summation n ranging from 1 to infinity a n cos of n pi x by l plus summation n ranging from 1 to infinity b n sin of n pi x by l, where, see, if you want to construct the Fourier series for the function, this is a formula. We can't construct directly without knowing a formula for a naught, a n and b n. Therefore, now finding a values of a naught, a n and b n, the formula for finding a naught and a n and b n is 1 by l, 0 to my a towards the interval a to a plus 2l f of x dx. an is 1 by l, a to a plus 2l f of x cos of n pi x by l, and bn is 1 by l, a to a plus 2l f of x sin of n pi x by l with respect to x or dx. Now, we are thinking about how we get this formula. Here I am not going to derive how we get to finding the values of a naught, a and b n for this formula. Because this derivation is not included in your syllabus. If you are really interested to know how we get this formula, you refer Gravel, your prescribed textbook Gravel, they given how we get the formula for finding a naught, a n and b n. Just I'm going to take this as a formula for construction of Fourier series. This Fourier series is also called trigonometric series. Why they treated this series is also trigonometric series. Suppose expand this series after you substituting the values of a naught, a n and b n, we get in the combination of sine, cosine and sine term. Sine and cosine terms are nothing but what? Trigonometric functions. The corresponding series is nothing but trigonometric series. Series means they are having infinite number of terms. They treated as trigonometric series. Either they are going to use the word Fourier series or maybe trigonometric series. Both are must be same only. Now with the help of these formulas, first you find out the values of a naught, a n and b n. Then you substitute and simplify that. We get the corresponding function, the construction of Fourier series. A naught, a n and b n are called Fourier quotients of the corresponding Fourier series. What I written the formula to find out these values of a naught, a n and b n are nothing but formulas are called Euler's formula or Euler's formula for the corresponding Fourier series. In the next step, see, always we are going to use this formula to construct the Fourier series, very tedious, very lengthy. For student benefit point of view, I am going to consider there are two cases. The case number one is, these two cases are nothing but the particular cases of the general one. What is my general one is, this is my general f of x is defined over the interval a comma a plus 2l. Now based on that, I'm going to consider two cases. Case number 1. The case number 1 is nothing but f of x is a function defined over an interval 0, comma 2l. Means what is my a value is 0. Suppose put a is 0, the interval is changed to 0 to l. What is a Fourier series for this function defined over the interval? The same formula for construction of Fourier series, a naught by 2 for n ranging from 1 to infinity, an cos of n pi x by l plus summation n ranging from 1 to infinity bn sin of n pi x by l, where a naught formula is same thing, but we are changing the interval. What is our interval here? Finding a naught value. Now we are changing 1 by L, the interval is 0 to 2L, f of x dx, and then an is nothing but 1 by L, 0 to L, 2L, f of x cos of n pi x by L with respect to x. Similarly, Bn formula is 1 by L, 0 to 2L, f of x sin of n pi x by L with respect to x. Now here, see, whenever our intervals start from 0, say 0, pi, like that. Now my L is, throughout my Fourier series class, L denotes radian or say positive integer, set of positive integer. Okay, either maybe L may be radian or maybe integer, just like 0 to 2 pi, 0 to pi, 0 to 1, 0 to 4, like that. Whenever the limit start from 0, in such cases we are going to use first case, we are going to construct the Fourier series. Now move to the second case. Case 2. Is this also particular case for the general one? F of x is a function over the interval minus L, comma plus L. Means what's the value of A is minus L. A is equal to minus L, that implies A plus 2L is what actually? Minus L plus 2L we get L. Therefore, what's the interval? Minus L to L. What is the Fourier series for this case interval minus L to L? It's the same formula, A naught by 2 for summation n ranging from 1 to infinity, an cos of n pi x by L plus summation n ranging from 1 to infinity, bn sin of n pi x by L. Now, how to find out the values of a naught, an, bn? A naught is 1 by L minus L to L, f of x dx, and then an is 1 by L minus L to plus L, f of x cos of n pi x by L with respect to x. Bn is 1 by L minus L to L, f of x sin of n pi x by L with respect to x. Now, whenever the interval is in the form of minus 1 to 1 or minus pi to pi, minus 2 pi to pi, like that, in such cases we are moving to second case, we have to construct the Fourier series. Now, instead of taking general a comma a plus 2l, what are the interval have? If you go through any textbook, either belongs to the first case or maybe belongs to the second case. Therefore, students easy to know that how to construct the Fourier series. For student benefit, here I am considering case number 1 and case number 2. Case number 1 in my Fourier classes, always the interval start from 0. Case number 2, the interval is in the form of minus L to plus L. Now, how to recognize I go for first case or second case? Why don't you take one simple example for identification of the cases? Now here, for example, suppose I want to construct a Fourier series for f of x is equal to x square over the interval 0 to 2 pi. Yeah. The most of the students are doing mistake here. Whenever start from 0, whenever I have to start from 0, I have to move for which case? First case. What's the first case says? 0 to 2L. If you want to consider the Fourier series, first you have to know very carefully the value of L. Taking value of L is a very important. Suppose you are not identified properly the value of L, even though you spend half an hour to construct the Fourier series, you are going to lose full marks. Therefore, once you identified from the interval, this interval is in the form of which case? First case. What's the first case interval is 0 to 2L. Equate 0 to 2L to the given interval 0 to 2 pi. Then you compare the upper limit. 2L is equal to 2 pi. That implies what we get, the value of L is pi. Once we get the value of L is pi, next try to find out what is n pi x by L. What is my n pi x by L? N pi x by L is pi is cancelled, we get nx. Based on that, we have to construct Fourier series for the function f of x over the interval 0, 2 pi. Okay, then we get what's our Fourier series here? F of x is equal to a naught by 2 plus summation n ranging from 1 to infinity an cos nx and then plus summation n ranging from 1 to infinity bn sin nx. Where what is my a naught is 1 by L. What is L? Formula is 1 by pi. 0 to 2L is 2 pi. L is pi. F of x dx. What's the formula for finding an is 1 by L is pi. 0 to 2 pi f of x. Yeah. See, after you construct the Fourier series only, better to write the a naught en. A naught is nothing but what you written inside the summation. Instead of en, what we are going to take? F of x cos nx with respect to x. Because most of the students, while writing a formula for a naught, en and bn, are doing mistake. Then if you want to overcome that, you go for this. Instead of bn, we have to replace it f of x. Sin nx with respect to x. And then you find out a naught, an and bn. We get the values for these Fourier quotients. Substitute in the where in the Fourier series expansion, we get the corresponding Fourier series for each function x square. Now first you identify the interval, based on that move to the next step. The next step is actually, for example, second example I am going to take now. This example 2 is, for example, I want to construct a Fourier series for the function f of x is nothing but, say, some sin x over the interval 0, 2. Whenever you start from, it's better you to take 0, 3. Whenever the interval start from 0, I go for which case? First case. Go for first case means, how first you identify the value of L. How to identify the value of L? Equate to the general limit of the first case, 0 to 2L. 3 is equal to 2L. That implies what is my L? 3 by 2. That implies what is my 1 by L is 2 by 3. Therefore, what is my n pi x by L? 1 by L is 2n pi x by 3. You don't do it orally. I am requesting everyone, please do it manually. Then I have to avoid the mistake. Most of the students, they are not doing manually. They are going to take orally. Suppose you are not pick correct value of L, the entire construction is wrong. Must and should have to do it, and immediately fraction second we get the value of L and also n pi x by L. Based on that you construct the Fourier series. Suppose I am going to take another one example. Say the third example is Fourier series. So you have to construct the Fourier series for the function f of x equals, say, some cos x over the interval minus pi, plus pi. Now here, observe carefully, this interval belongs to which case? Second case. What is my second case interval? Minus L to L. First you have to know what's the value of L, what's the value of L here? How to compare? You compare with what we did for the first case similar way. Compare with the limit of the second case to limit of the given interval. Take upper limit. What's upper limit? L is equal to pi. For L is equal to pi, that implies what is my n pi x by L is nx. Now based on that you construct the Fourier series. What is Fourier series? Is a naught by 2 plus summation n ranging from 1 to infinity a n cos nx and also summation n ranging from 1 to infinity bn sin nx, and then you write the formula for a naught, an and bn. 1 by pi, L is pi, minus pi to plus pi, f of x dx, and also an is what? 1 by pi, minus pi to pi, f of x cos nx with respect to x, and also I have to write the formula for bn. What's the formula for bn? Is 1 by pi minus pi to plus pi f of x sin nx with respect to x. Now, this is a way to construct the Fourier series, either belongs to the first case or belongs to the second case. First case is 0 to 2l. How to take the value of l in 0 to 2l? Equate upper limit of the first case is 2l to the upper limit of the given interval. Compare it, simplify that. Automatically we get the value of l. From that you find out n pi x by l. And then you construct the series. Suppose the Fourier given function, the corresponding interval is in the form of second case. What's the second case is? Minus L to L. In such cases, again, same thing, equate that given interval to the interval of the second, general interval of the second case, minus L to plus L. Equate, we get the value of L, and then simplify L, find out corresponding n pi x by L, and then you construct the Fourier series. Then keep in mind, before going to construct the Fourier series, first you observe the interval. Either interval belongs to the first case or second case. Whenever start from 0, that is my first case. Whenever start from negative to positive, that move to the second case. Based on that, apply the first case, you find out the value of L, and also find out n pi x by L, you construct the Fourier series. And then suppose is in the form of second case, you compare with the upper limit of the corresponding given interval, find out the value of n, and then find out n pi x by L, construct the Fourier series, and also write the corresponding formulas for a naught, n and bn. And then you have to continue the rest of the thing. Thank you very much for listening my talk. I'll come and explain some more cases in my next class. Thank you.